Thank you very much for the introduction. So I'll be presenting on the effect of Bacillus subtilis and its delivery route on hatch and growth performance, blood biochemistry, and immune status of broiler chickens. I start off with a few background information. So the poultry industry continues to face several challenges. Chief among these challenges includes the challenge of combating economically important poultry disease, as other speakers have highlighted. Also, there's the challenge of increasing feed ingredient prices and nutrient indigestibility. And more recently, there have been increased demand for antibiotic-free poultry products. As a solution to these highlighted challenges, several bioactive substances are currently being experimented, including phytogenic feed additives, prebiotics, and probiotics, just to mention a few. But these bioactive substances are currently being delivered through the conventional delivery route, that is either through the feed or through the water. And research has shown that the efficacy of these bioactive substances could be impaired by the limitations that characterize the conventional delivery route. For example, it is possible that they negatively interact with other dietary feed additives like oligosaccharides and coccidiostates. It's also possible that when feed milling processes like pelleting and extrusion could render them potentially thermally unstable. When supplied via the water, it will depend on the quality of the water, the volume of water intake, as well as the quality of the chick watering devices. To overcome these limitations, a novel technology has been proposed. In simple terms, the novel technology is the delivery of these substances directly to the developing embryo. It offers a few advantages, one of which is an economic advantage in that lesser quantities of these bioactive substances are needed. Also, because it's a direct inoculation, it eliminates the risk of pathogenic contamination. It also gives us an opportunity to mitigate the perinatal nutritional deficiencies that chicks often encounter. It also gives us a rare opportunity of colonizing the chick microbiota very early on. As I mentioned, several bioactive substances are currently being researched as alternatives to antibiotics, including probiotics. But the question is, why probiotics? Several research have shown and have found the immunostimulatory properties of probiotics, their gut-enhancing properties, the ability to ensure positive gut homeostasis, which includes improved nutrient digestibility and ultimately improved growth performance in birds. In early 2021, our research lab conducted a research using a probiotic product known as Bacillus subtilis fermentation extract at a dose of 10 times 10 raised to 6 CFU per ml. We evaluated the effect of this probiotic product on hatch and growth performance and short-chain fatty acid, as well as other parameters in broiler chickens. The results showed that this probiotic product at this dose enhanced gut morphology without altering both growth performance and hatch performance in broiler chickens. Subsequently, the objective of this current research was to evaluate 2 doses of this probiotic product, that is the 10 times 10 raised to 6 CFU per ml and 20 times 10 raised to 6 CFU per ml, both via the in novo and in-feed route on parameters that include hatch and growth performance, blood biochemistry, and immune status of broiler chickens, all compared to an in-feed antibiotics. In terms of methodology, about 1,860 eggs were sourced, divided into 4 treatments. The eggs were incubated for 21 days under standard hatchery conditions. They were candled on day 12, and on day 18, the eggs were injected using previously described method. Each egg received either 0.2 ml of saline or 0.2 ml of either of the in novo probiotic dosages. In the barn, the hatch chicks were allotted to 5 dietary treatments. We had a corn with soy boeing meal, which was the negative control treatment, an in-feed antibiotic treatment, an in-feed probiotic treatment, and of course the 2 described in novo probiotic treatment. There were 9 replicate pens per treatment. There were 22 beds in a pen, and the beds were raised for 35 days under 3 phases: a starter, grower, and a finisher phase. Diets were formulated in accordance to NRC nutritional guidelines. In terms of data collection at hatch, we evaluated hatchability, chick weight, chick length, and naval score. And every week we recorded feed intake and body weight to subsequently calculate average feed intake, average body weight gain, and feed conversion ratio. At day 25, we sampled 1 bed per pen to to furtherly evaluate these highlighted parameters. In terms of statistical analysis, we use a general linear model to evaluate the ensuing data, and when found significant, they were separated using Turkey on a significant test in the Minitab statistical package. Now we move on to our results. Here I present our results on hatch performance and chick quality. We observed that our treatment did not affect hatchability, average chick weight, average chick length, and average NAVS score rather. But we consider a result on hatchability quite important. We observed that at least 95% hatchability across all treatment. This is important because it shows that our novel delivery method did not impair hatchability, which could affect the commercial acceptance of this technology. In terms of growth performance, in week 1, we observed that there was no effect of treatment on average feed intake, but the in-feed probiotic treatment showed a tendency as much as 7% to increase the average body weight gain of the birds compared to the negative control treatment. This subsequently disappeared in subsequent weeks. In week 5, we saw that the antibiotic treatment showed significant effect increase in the average feed intake of the bird as much as 16% compared to the in-novo probiotic treatment too. But this did not translate into improved body weight gain in the birds. This similar trend was recorded in across the entire trial period. At day 35, we see that the antibiotic treatment recorded a tendency as much as 3% to increase average feed intake, but no subsequent effect in average body weight gain, suggesting that other treatment had similar nutrient coverage efficiency compared to the antibiotic treatment. Our result on blood biochemistry showed that the antibiotic treatment did increase the levels of blood electrolyte levels of sodium and chloride as much as approximately 2 and 4% respectively. Compared to negative control, other treatment recorded intermediate values of these blood electrolyte levels. This is particularly important because of the physiological roles that this blood electrolyte play, which relates to maintenance of acid-base balance and osmotic balances in the bodily fluids. Although the levels of this antibiotic treatment were in the upper range for reference values, it's important to keep the blood levels of the electrolyte levels in optimum range, because excessive high levels of these blood electrolytes are referred to as hypernatremia and hypoalcoholemia, have a negative effect on the birds. This is perhaps another reason to discourage the continued use of antibiotics in broiler production. Here we record our effect of treatment on relative weight of immune organs. We see no effect on both the bursal and the spleen. Here we report our results on serum hemoglobin. Although we report no effect on hemoglobin M, we see a significant effect of our novel delivered probiotics on the levels of hemoglobin G, as much as a 91 and 99% decrease in immunoglobulin G was observed in the novel probiotic and the novel probiotic treatment respectively. The immunoglobulin G is the major hemoglobin secreted in response to infectious agents in the body, which is important to note that there was no immunological challenge in this study, suggesting that the novel probiotics treatment converted some sort of immunocompetency in the bird, neutralizing pathogenic organisms, and such having no need to produce natural antibodies in the birds. Based on our result presented here, our results suggest that these probiotics delivered through this route could offer better immunocompetence to the bird without affecting both hatch and growth performance. And also based on our results, it would be important to further evaluate these probiotics under an immunologic challenge model. These are my references. I want to thank the fellow organizations for their support. At this time, I want to say thank you for listening.
All right, folks, if you can enter any questions you have for Samson in the Q&A box, that would be great. In the meantime, I have a couple questions here. So I noticed that you were talking about doing navel scoring, and I'm not super familiar with the scale for that. Can you explain that to me? Or maybe it was in an earlier slide that I didn't catch. So I think the average was about 1.4. So is 0 a perfectly healed navel, and what's the scale for that?
All right. Sorry, I'm just looking for the particular slides.
It was on a table with results.
Okay.
It was a yellow table, sorry. Right there.
All right. So we had 3 navel scoring methods. So one was a perfectly healed navel. 2 was a navel scoring with at least a 2 millimeter opening. So it had a not completely healed navel with a 2 millimeter opening. And 3 was a navel score with greater than a 2 millimeter opening and 13 navel. So the average here is the number of beds with 1, number of beds with 2, number of beds with 3. So this is where the average is calculated.
Okay, perfect. No, I just was wondering what the scale was on. So it was 0 to 3 basically, right?
Yes, please.
Okay, and then I know when you talk to producers and you're trying to get them to try something new, their question always revolves around cost and return on their investment. So like, do you have an idea if this is ever offered commercially, what the cost for this probiotic injection would be, maybe compared to what it costs to include BMD in feed? And then like your data was showing that there really wasn't any improvement in body weight gain. Is that correct? So to me, it's like, I mean, it might be a more attractive option if BMD is eventually pulled from available medications for broiler producers. But yeah, that's a bunch of questions all at once, if you want to try and address them, Samson.
All right, so when I was giving a background of Innovo technology, one of the advantages I did mention was that it offers an economic advantage. If we compare a one-time delivery compared to successive delivery in feed, it is in the long run cheaper to use the Innovo routes because it offers an economic advantage, as I did point out. Then you were asking of the economic relevance to commercial producers. So I do know that if, like I mentioned, a one-time is cheaper, and also, although performance was not increased in our studies, it offers an immunological advantage in terms of preventing disease. So if you have an healthy bed, it's obviously better than a dead bed, and that is of commercial relevance to commercial producers. So if you have healthy chicks and lesser inputs in terms of cost of additives, I think in the long run, it adds up to profitability.
Okay, and then I have one more quick question. Do you know, like if you're planning to do an Innovo injection with probiotics at the hatchery level, can it be done in combination with Innovo vaccinations if that's something that's required at the hatchery?
All right, so the way we structured, sorry, I'm just gonna look for a slide that talks about the time of injection. All right, so I did specify that we injected on day 18. So for commercial producers, this is about the time when they switch from incubator setters to incubator hatcher. So if you could have Innovo vaccination at that time point, it makes it a whole process which goes seamlessly. So it can work. We did on day 18, and that's about the time when they switch to the hatchers. So it can work.
Sure. Okay. Well, thank you very much, Samson, for your presentation.